Well, that's all I want to say on the subject, but I want to make a few remarks about some characteristics. Here we have an example in which an obvious effect, the irreversibility, is not an obvious consequence of the laws, but that the effect is rather far from the basic laws. It takes a lot of analysis to understand why this effect, and that the effect is of first importance in the economy of the world, in the real behavior of the world, in all obvious things, that my memory, my characteristics, the difference between past and future are completely involved in this, and yet the understanding of it is not prima facie available by knowing about the laws. It takes a lot of analysis. It is often this way, that the laws of physics are different, or the laws of physics do not have a direct relevance, obvious relevance to the experience, but that the laws are abstract from the experience to varying degrees. In this particular case, the fact that the laws are reversible, although the phenomena are not, is an example. There are often great distances between the detail laws, and the main aspects of real phenomena. For example, it's something of this kind, that if you watch a glacier from a distance and you see the big rocks falling into the sea and the way the ice moves and so forth and so on, it isn't really essential to remember that it's made out of little hexagonal ice crystals, that the ice crystals are hexagonal. And yet, the character of the little hexagonal ice crystals, if understood well enough, is in fact the consequence of this is in fact the motion of the glacier. But it takes quite a while to understand. In fact, nobody knows enough about ice, no matter how much they study the crystal yet, to really understand all the behavior of the glacier. But the hope is that if we do understand the ice crystal, we'll ultimately understand the glacier. But there's a large, in fact, although we've been talking in these lectures about the fundamentals of the physical laws, I must say immediately that one does not, by knowing all the fundamental laws as we know them today, immediately obtain an understanding of anything much. It takes a while, and even then it's only partial. Nature, as a matter of fact, seems to be so designed that the most important things in real world seem to be a kind of complicated accidental result of a lot of laws. To give an example, nuclei, which involve several nuclear particles, protons and neutrons, are very complicated. They have what we call energy levels. They can sit in states or conditions of different energy values. And various nuclei have various energy levels. And it's a complicated mathematical problem, which we only can partly solve, to find the position of the energy levels. Now, it's not, you can understand that it's complicated, and therefore there's no particular mystery about the fact that nitrogen with 15 particles inside happens to have a level at 2.4 million volts, and another level at 7.1, and so on. And the exact position of the levels is obviously a consequence of an enormous complexity. But the remarkable thing about nature is that the whole universe in its character depends upon precisely the position of one particular level in one particular nucleus. In the carbon-12 nucleus, there's a level at 7.82 million volts. It so happens. And that makes all the difference in the world. The situation is the following, that if we start with hydrogen, and it appears that in the beginning or in the earliest times, the world was practically all hydrogen. Then, as the hydrogen comes together under gravity and gets hotter, nuclear reactions can take place and it can form helium. And then the helium can combine only partially with the hydrogen and produce a few more elements, a little heavier, but they disintegrate right away back into helium. So that it was for a while a great mystery about where all the other elements in the world came from, because starting with hydrogen, the cooking processes inside the stars would not make much more than helium and a few others, half a dozen other, less, as a matter of fact, other elements. And faced with this problem, Professor Hoyle said that there is one way out. I think saltpeter also, he's here, so I have to be very careful. If 3 helium atoms could come together to form carbon, we could easily calculate how often that should happen in a star. And it turned out it should never happen much, except for one possible accident. If there happened to be an energy level at 7.82 million volts in carbon, then the 3 helium atoms would come together, would stay a little longer than they ought to, on the average, if there were no level there, before they come apart. And staying there a little longer, there's enough time for something else to happen and to make other elements. And if there was a level of 7.82 million volts in carbon, then we could understand where all the other elements in the periodic table come from. And so, by a backhanded, upside-down argument, was predicted that there is in carbon a level at 7.82 million volts, and then experiments in the laboratory with carbon show indeed that there is. And therefore, the existence in the world of all these other elements is very closely related to the fact that there is this particular level in carbon. But the position of this particular level in carbon seems to us, after knowing the physical laws, to be a very complicated accident of 12 complicated particles interacting. So I wish to illustrate by this example that an understanding of the physical laws doesn't give an understanding in a sense of understanding significance of the world in any way. The details of real experience are very far often from the fundamental laws. There are, in a way of speaking, in the world, we have a way of discussing the world which you could call, we discuss it at various hierarchies or levels. Now, I don't mean to be very precise, this as a level, as another level, and another level, but I will indicate by describing a set of ideas to you, just one after the other, what I mean by hierarchies of ideas. For example, at one end, we have the fundamental laws of physics. Then we invent other terms for concepts which are approximate, who have, we believe, their ultimate explanation in terms of the fundamental laws. For instance, heat. Heat is supposed to be the jiggling, and it's just a word for a hot thing, is just a word for a mass of atoms which are jiggling. For that, fundamentally, we should think of the atoms jiggling. But for a while, if we're talking about heat, we sometimes forget about the atoms jiggling. Just like when we talk about the glacier, we don't always think of the hexagonal ice snowflakes which originally fell. Another example of the same thing is a salt crystal. Looked at fundamentally, a lot of protons, neutrons, and electrons. But we have this concept, salt crystal, which carries a whole pattern already of fundamental interactions, or idea like pressure. Now, if we go higher up from this, in another level, we have properties of substances like refractive index, how light is bent when it goes through something, or surface tension, the fact that the water tends to pull itself together, is described by a number. I remind you that we have to go through several laws down to find out that it's the pull of the atoms and so on, but we still say surface tension, and don't worry when we're discussing surface tension of the inner workings, always. Sometimes we do, sometimes we don't. Go on, up in the hierarchy. With the water, we have the waves, and we have a thing like a storm. We have a word for storm, which represents an enormous mass of phenomena. Or sunspot, or star, which is an accumulation of things. And it's not worthwhile always to think of it way back. In fact, we can't, because the higher up we go, we have too many steps in between, each one of which is a little weak, and we haven't thought them all through yet. If we go up in this hierarchy of complexity, we get to things like frog, or nerve impulse, which you see is an enormously complicated thing in the physical world, involving an organization of matter in a very elaborate complexity. And then we go on, we come to things, words, and concepts like man, and history, or political expediency, and so forth, which is a series of concepts that we use to understand things at an ever higher level. And going on, we come to things like evil and beauty and hope. Now, which end is nearer to the ultimate creator, or the ultimate? So if I make a religious metaphor, which end is nearer to God? Beauty and hope, or the fundamental laws? I think that the right way, of course, is to say that the whole structural interconnections of the thing is the thing that we have to look at, and that the sequence of hierarchy, that all the sciences and all the efforts, not just the sciences, but all the efforts of intellectual kind, are to see the connections of the hierarchies is to connect beauty to history, is to connect history to man's psychology, the man's psychology to the working of the brain to the neural impulse to the chemistry, and so forth, up and down, both ways. And today we cannot, and there's no use making believe we can, draw carefully a line all the way from one end of this thing to the other. In fact, we've just begun to see that there is this relative hierarchy. And so I don't think either end is nearest to God's. And it's to stand at either end and to walk out off the end of the pier only, hoping out in that direction is the complete understanding, is a mistake. And to stand with evil and beauty and hope, or to stand with the fundamental laws, hoping that way to get a deep understanding of the whole world with that aspect alone, is a mistake. And it is not sensible either for the ones who specialize at one end and the ones who specialize at the other end to have such disregard for each other. They don't, actually, but the people say they do. But that actually the great mass of workers in between, connecting one step to another, are improving all the time our understanding of the world, both from working at the end and working in the middle. And in that way, we are gradually understanding this connection, this tremendous world of interconnecting hierarchies. Thank you.